I've already recorded video. If you don't want to listen live, I have the recorded videos also for the same slide, same presentation. Anyway, so in the beginning of the operating system class, I discussed that operating system works as a resource manager and it works as an interface between the user and the low-level hardware. In that perspective, there are four major pillars of operating system. One is called as process management or CPU management, where you have a set of processes that you want to execute by your system, and you may have one CPU or dual core or quad core machine, where you need to schedule these CPUs, these processes to the available core or CPU such that the total execution time will be less. That means you want faster device. So that was one pillar of the operating system. The second pillar of the operating system is memory management. So here the memory means main memory, where you may have a 2 GB RAM or 4 GB RAM or 8 GB RAM, whatever. On that RAM, you are going to execute 5, 6, 10 programs simultaneously. So you have a concurrent executable program that you are going to execute at the same time with a limited RAM size, maybe 4 GB RAM or 8 GB RAM or maybe 16 GB RAM. So how efficiently that 4 GB, 8 GB or 16 GB RAM will be dynamically allocated to this concurrently executable program. So that was the function of operating system, to allocate and deallocate. So that's why the second pillar of the operating system is memory management. The third one is file system interface and the mass storage or hard disk management or secondary storage management. File system storage, file system interface and secondary storage management. This is the third pillar. And the fourth pillar is I/O management. Whatever input output device you have, starting from your monitor, keyboard, mouse, your speaker, your headphone, your webcam, whatever you have, printer, scanner, all these are input output device. So how this input output device will be connected in your system, that is also managed by the operating system only. So these are the four major pillars of operating system. So the third pillar that we had is file system interface and hard disk management. Okay, so when you store at the beginning, when you purchase a hard disk or when you purchase a machine, maybe with a 500 GB hard disk or maybe 1 TB hard disk, you cannot store any file or any document on your hard disk unless you have a operating system on it. So to make the hard disk accessible by the user, you need to have a proper operating system. That operating system will give you an interface of, or you can call it as a virtual interface of the hard disk, where you can see you have a C drive, D drive, E drive, F drive, or depending on the number of partition you did. You may create one partition, so it will be a single partition hard disk. You can create two partition, C drive, D drive. You can create three partition, C drive, D drive, E drive. Now on that partition, so these are all virtual partition of the same hard disk, that 500 GB hard disk. On that hard disk of 500 GB, you have created three drive. Drive C, drive D, drive E. In drive D, you may create number of directory, and each directory may consist of number of subdirectories. Each subdirectory may contain number of another level of subdirectory where you can keep your different files. What are those files? It can be .txt file, it can be .doc file, it can be .py file, Python file, it can be .java file, it can be .c file. Okay, so depending on the requirement you have to create your file, or depending on the application where you are using your file, that file extension will be created, and that you have to store in a proper directory. Why proper directory? The idea is very simple. You have a big shelf in your home. That shelf may have a separate partition. Now you may have a 2-3 siblings. Maybe you have a brother or sister or like that. So what you can do, you can divide the entire shelf to 2 partitions. One partition for yourself, another partition is for your sister or daughter, for your son, for your brother. So the entire shelf you have divided, the wardrobe you have divided in number of 2-3 partition. One for yourself, another for your sister. And in that shelf of yours, you can also make a 2 partition. One for the storybook, another for the academic book. In the academic book, again, you have divided into 2 parts. One is the regular course book, another set of book is for competitive exam book. So in this way, you have created number of directory and subdirectory, and within the directory subdirectory, you are keeping the book or copies. So these books and copies are the actual file, and the partition of that shelf is the directory and subdirectory. Okay, so the same analogy is applicable in computer hard disk in the same way. An operating system gives you that interface through which you can access those low-level hard disks. So whatever you call as a C drive, D drive, E drive, basically that is a virtual interface, but the actual hard disk is an electromechanical device where the data is stored like in a form of electronic charge. Now what is file? File is a contiguous logical address space. You have created a file, and that file is of maybe 250 KB. 250 KB may be an abc.doc file. So you have created a file that is in Microsoft Word. That's why the extension is DOC. The name of the file is ABC and the extension is .doc. So this 250 KB space, you are feeling it is a contiguous space. You are feeling it is a contiguous 250 KB space where the data is stored. But in a low-level hard disk, you don't know how it is actually stored. You don't know how it is actually stored. Even you don't know whether this 250 KB file is stored in your hard disk or maybe in a separate type of any drive like pen drive or something like that. So you are unaware about the fact because this is being abstracted by operating system. So operating system gives you a virtual feelings that you are storing your file in C drive or D drive or E drive. But all those C drive, D drive, E drive are denoting this low level hard disks, this electromechanical device. Now what are the types of the file? It can be data file, it can be numeric, character, binary file, even it can be a program file like .c. You have created the file in C programming language. You can create a file maybe .py, Python file, xyz py. You have created a file pqr.java. It is a Java file. So these are all program files which you can execute through proper compiler or interpreter. the file structure, it can be a sequence of words and bytes. The simple record structure, it can be line, some fixed length record, it can be variable length record. If you create a file, maybe whatever language, whatever applications you are using, it may be Notepad, it may be .doc, whatever. It is a collection of lines. It can have some fixed length or it can have variable length. The structure can be formatted document, it can be non-formatted or relocatable load file. You can relocate from one position to another position. Even it can be a program file, as I said, .c, .java, .py, which you can execute. But again, for executing that file, you need operating system. So all these things will be maintained by the operating system. Without operating system, you cannot create this thing. So whenever you purchase a machine or whenever you connect a new hard disk, the first thing that you need to have is the operating system. Through operating system only you can interact with this hard disk. It may be an SATA hard disk, it may be an SSD hard disk, even it may be an pen drive also. But unless you have an operating system, you cannot access it. You are not able to store or keep file folder. What are the file attributes? It will have a file name. So in one directory, the file name should be unique. File name with a combination of extension. So that should be unique. Only information kept for human readable, with which you can read the file name. That is abc.x, abc.c. So I can understand that abc is my this file. So is the name of the file. Then you have an unique identifier, just like you have a roll number or registration number, which is an unique identification as a student of NIT Durgapur. In the same way, each file will have an unique ID, which uniquely identified by the system that this is this file. So this unique identifier or identifier is used by the system to uniquely identify the file. But whereas the name of the file is used to identify the user. I mean, user can identify the file with the name, not the through identifier. Then the type, whether it is a .doc, .docs or .txt, .py, .java. So depending on the application where you have created the file, that is your type of the file. Then the location of the file. So from C drive, under the C drive, you may have a directory. In that directory, you may have another subdirectory. In that subdirectory, you may create a file. So that is the location pointed to the file locating on the device. So within the device where the file is actually located. Size. Of course, it is not fixed. When you create a file, it will have a size. Next, if you update with some new data, or if you delete some data from the file size will be increased or it will be reduced. Either it increased or it is reduced, the size. So the size is dynamic depending on the data you are keeping. Protection. When you create a file, there must be an user of the file. So if you create a file as an admin of the system, so you are the user. Then you can give some kind of control on the file that this machine may be used by 2-3 people, but you want that each one will have a separate username and password. So a file created by you will not be accessible by other person. So you are giving some kind of access control and protection, that you can access the file, but you are not giving the permission to other people to access that file. Or you can read, write, execute the file, but you are giving permission to other people of the system only to read the file, not writing anything or executing anything. So this type of mechanism, that type of protection can be given on the file. And again, this is provided by the operating system. And those people who are familiar with writing code or doing some kind of file operation in Linux operating system, you are very familiar with every time you need to give some kind of permission. Mostly for Windows operating system, these permissions are provided by default, most of the cases. But for Linux, every time you do anything, you have to take several permission. You cannot copy a file from one directory to another directory unless you have an admin password. Next, you have the time, date, and user identification. Who has created this file? Who as a user who created this file? What is the date of the file of creation? What is the date when the file was created? What is the time when the file was created? So these are some of the information related to file. And all these informations, the name, file ID, type, location, size, protection, date, time, identification, all these informations are kept in the directory structure. So directory and the file is the similar of your content page of the book and the actual chapter. So directory structure is the content page of the file, content page of your book. And the actual content, to retrieve the actual content from the book, you need to reach to that particular page. So maybe if you open the operating system Galvin book, I mean for all book you will find the same structure. In operating system Galvin book, if you open it, you will have a content page, and you want to reach to the virtual memory topic. So what do you need to go? You have to check the content page and you to see where the virtual memory exists. So you will see that the virtual memory topic is in page number 220. So to read that particular topic from Galvin book, you have to go to the page number 220 to retrieve those information. And the same thing happened here. You have a file directory structure. From there, you can search where your file is, or where the data is which you are looking for. You are looking for some data and where that data is. So that will tell you that what is the location of that particular data. So operating system will take you to that physical location of the hard disk where the data is actually located. And that is being done by directory structure. If you have any questions, you can ask me. It is something like I am giving a recording slide. It looks like to me, because nobody is asking any question, nobody has any doubt, blah blah blah. Okay, fine, no problem.
No sir, no doubt.
No, so that's what I'm telling. So it's better I can give you this recorded lecture, because you don't have to waste the time here. What are the different operations of the file? So file is an abstract data type. Can you define abstract data type? What is abstract data type? Anyone? From the data structure point of view?
So abstract data type is basically when we don't discuss the actual implementation, but we are thinking about how it will function and what its logic will.
So it's all about how the actual implementation is abstracted. Actual implementation is abstracted, and it is identified with some kind of functionalities associated with it. In the same way, file is an abstract data type which has different types of functionalities. What is the different types of functionalities? Create. is a function with which you can create a file. Write is another operation. Create is an operation, write is an operation with which you can write something on the file. Read, you have already an existing file in your one of the drive or in a hard disk or in a directory. You want to read some information from that file. So reading the file. Reading from the file. Reposition within the file. You are in a particular position, you want to change it, location, your read write head. You want to delete the entire file from the hard disk. Maybe in C drive, you have a directory, and in that directory, you have a subdirectory, and that subdirectory may contain a file, and that you want to delete. So, this operation. Truncate. You have a file, lot of data are there. You want to delete this portion of the file. You want to delete this portion of the file. Next, you can open a file, search the directory structure on the disk for entry of the file fi and move the content of the entry to memory. That means you have already a file in one of the directory or subdirectory, and that you want to open. Open means you want to bring the file from your hard disk to the main memory such that you can read it or you can write something on it. So before reading or writing to and from a file, you have to open the file from the hard disk, because directly from hard disk you cannot read. So you have to open it, and once you open it, the file content will be coming to the main memory. From there you can read it, or if you write it, it will be written on the main memory first, then it will be saved to the hard disk. It will be saved actual hard disk. So that's why that is the purpose of opening a file. Once you open a file, after doing all the operations, the side reading, writing, whatever, truncate or whatever you do, and then you have to close the file. If you don't close the file, then maybe you may lose some data, because unless you close the file, it will not be saved permanently. So there is a possibility that some of the information that you have written may be lost. While opening a file, open the location of the file and the mode you have to write. Whether you want to open it in a read mode or write mode or executable mode. You have to give the entire path here. This will return a file pointer, FID you can call. The moment you take admission at NIT Durgapur, you will be given a roll number and registration number. The moment you open a file, the file is available in the hard disk. The moment you open a file, it will give you an FID. That is file identifier, a file pointer.
So just like processors, whenever we need to open a file, we have to load it in our main memory. Then only.
Right, the same way. Very good, the same way. So your file is already in the secondary disk. You want to read it or you want to write something on it. So to do that, you have to open the file. How do you open? With this system called open, the entire path name and the mode on which you are trying to open. Read mode, write mode or execute mode. It will return a file ID, that's file pointer, FID. Okay. Now this can be different types of file extension depending on the applications where you are creating a file. If you create a file in the older version of Microsoft Word, it will be .doc. If you create in the newer version like 2016 or 19, it will give you .docs. If it is an HTML file, the extension will be .html. If it is a C file, it will be an .c file. So it can be executable file. So the possible extension are like this: .exe, .com, .bean, like this. If it is an object file, .obj or .o. If it is a source file, then .c, .java, .py, these are the source file, which is containing the source code of a program written in a particular programming language. Source code of a program written in a particular programming language, maybe C, Java, Python, whatever. Now you have another is called batch file, where you have a collection of commands that you want to execute some one by one at a time. I mean, you have written all the commands together and that you want to execute. You don't want to write the command one at a time. Rather, you have written all the command in a file and that you want to execute by the system. So .bat or .sh, the cell file. Then you have a text file .txt. Word processor, there can be different word processor today. You have WP and .tex, TX is a LaTeX file, is a scientific writing tool. RTF, .doc. Similarly, you have library files, .lib, .a, .so, .dll. DLL is a library. Print or view, the popular one is PDF, .pdf. You have also
So what
PS.
does library files do?
Library files, like if you have a like compiler, okay, and there are library functions that you want to use. So those library
Okay, sir.
functions, they may be written in some file of the compiler. That file is called library file. Similarly for the operating system as well. If you open the Windows system file, the most of the Windows system file are of extension is .dll file. So .dll is the library file of Windows, or you can say system file of Windows. Then you have archive like .arc, .zip, .tar file, which allow you to compress. Then you have multimedia file .avi, .mp3, .mpeg, like this. Now, what are the access method? You have a file. You have a file in your hard disk that you have created. Maybe it contains the information of 100 students. Okay, their name, roll number, date of birth, address, blood group, etc., etc., semester marks. Now you have information of 100 students in a single file. Now to retrieve the information from there, how can you access it? So you have a large file. You have a large file that composed of number of information. Record of 100 students. So when you give a command, your read write head, which is going to read the file, is it in the topmost position? This is called read write head. It is in the topmost position of the file. This is in the topmost position of the file. Suppose you want to access the information of this person. The one method is you can go sequentially one by one. This is called sequential access. So you can reach one to the second to third, the third to fourth, then fourth to fifth, then fifth to sixth. Maybe the seventh one is your target one. So you have to reach one at a time. One to second, then second to third, third to fourth, fourth to fifth, to sixth. This is one approach. How can you go? You can go by read next or write next. Or you can reset it to bring it to the previous position, the first position. So read, write, next, reset. So this is called sequential access. You are moving your read-write head in a sequential manner. The other approach can be direct access. Your read-write head was in the first position. You give a command that I want to read this particular information. Your read-write head will directly go to this position. This is called direct access. So depending on the operating system functionalities, you can move your read-write head from first position to the 10th position, either sequentially or direct access. If you go for sequential, then you cannot skip. You have to go one at a time, one the first, then the second, then the third, like this way. If you go for direct access, you can reach to any position at any moment of time. The thing that I discussed. So if you have a current position, this is your current position of the read-write head. For sequential access, you have to go next, then next, then next, then next, then next, then next. Similarly, if you go to the beginning, rewind, 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 like this way. You cannot directly reach to the particular location. This is not allowed. Organization. Okay. Now you have directory structure. So as I told you at the beginning, that how directory structure is analogous with the shelf you have in your house. You have a big shelf and that you share with your sister or brother. Now you have a big shelf that you can consider as a drive, maybe D drive or E drive. That shelf you have divided into 4 partitions. Top 2 partitions are for you. The lower 2 positions, 2 shelf or 2 partitions are for your sister. It will be easy for you to access any book or copy from the shelf. That's why you divide it. Then among these two drive of you also divide into 2 or 3 subdirectory, like 2 or 3 partition, virtual partition, where one partition is fixed for keeping the copy, one partition is fixed for keeping the books, another partition is fixed for keeping the storybook, another partition is fixed for keeping the competitive exam book. Why you did it? You did it because it will be easy for you to directly reach out to that particular location and access that particular file, to particular book. In the same way, you have a directory. Within the directory, you have different files, F1, F2, F3, F4. So you can consider these as the books or the copies you have. Mind it, both this directory structure and the actual file both reside in the hard disk only. Just like the content page and the actual content of the chapter both reside in the same book. In the same way, the directory structure and the actual files both resides in the same hard disk. So suppose you have one disk, this one, you have created two partitions, partition A and partition B. You have created two partitions of it, partition A and partition B. Now, in partition A, there are number of directory and subdirectory. That means the content page. So that will be stored, that information will be stored in the directory part. This is the directory part of the hard disk of this particular drive. And these are the actual files. These are the actual files of that drive or that partition. So partition A is a partition, one partition of disk 1. Partition B is another partition of disk 1. So partition 1 has a directory structure, partition B has also a directory structure. Partition A has a directory structure. That directory is containing the content page, the directory information of these files, which are stored in partition A. Directory structure of this, that is in partition B, is containing the content page or the directory information of the files that are stored in partition B. You may have a partition C that consists of two disks, disk 2 and disk 3. At the beginning, I told you these partitions are the virtual partition. So it apparently looks like that this is the two disk, but actually this one has two partition, partition A and partition B. In the same way, we can say there are two partition, two disk, disk 2 and disk 3. But virtually it is reflecting to the user as partition C because you have created the partition like that way. So if it is partition C, so all the files available in this partition C, this directory structure will be here only. So this directory structure is the content page. This directory structure is the content page of the files stored in partition C. Clear?
Yes.
Sir, if in the second case, if a file is stored somehow partly in disk 2 and partly in disk 3, and then one disk fails, sir, then what will happen?
See, of course that file will be corrupted. Definitely, there is no way of saying this thing. The file will be corrupted. But normally, क्या होता है? When we say the hard disk is crashed, or when we say your Windows has crashed or your Linux has crashed, this is a very common phenomenon that happens with everyone of us. That suddenly you saw that your Windows has crashed or your operating system has crashed. When you say your operating system is crashed, maybe Windows or Ubuntu or whatever, basically operating system gives you this, or operating system is the manager who is managing these directory structures, this directory structure. So as the operating system is corrupted or crashed, you are no more able to access this directory. You are not able to access this directory, but your files will be as it is. So you have a book maybe Galvin book operating system, or maybe Silverchair this database book. You have a book, and one of your notorious friend has taken the pages of content page. He destroyed your content page of the book. Now it will be very difficult for you to reach out to a particular chapter or to a particular portion of the book or a particular topic of the book. It will be very difficult for you to reach there. In the same way it happens. If somehow your hard disk is, if your operating system is crashed, your files will be there. In that case, with some bootable disk, you can run the operating system, you can access the hard disk, but you can, as you don't have the directory, so you have to access the files in a big, what do you say, in a big mess, where you will find all the files of this drive. So you will if you go to disk 1, you will find the files of partition A, you will find the partition B, or even if you have a lot of directory, subdirectory, all files will be dumped up in one place. All will be dumped up in one place. Maybe you don't have you don't find the name also, because all these are maintained in the directory itself. So if your directory is corrupted, how can you retrieve it? You will find all are available, but you won't you cannot identify which one is which. বুঝতে পারলে অর্ক?
হ্যাঁ স্যার, থ্যাংক ইউ।
Now, what are the operations performed on directory? So you have as I told you, you have a directory. Directory is just like content page, and both the directory and the files are stored in the hard disk only. As both the content page and the actual chapters of the book is in the book itself. In the same way, the directory and the files both are in the hard disk itself. What are the operations that can be performed in directory? So directory is just like, again, I am repeating the same thing. The directory is just like a content page of your book. You can search for a file, you can search for a topic. You can search for a topic. You can search for a chapter. You can create a file. So you can create a file, and that you can connect in a particular drive or particular directory. As if you are a writer, you are putting one more pages, one more chapters, and that you are adding in the content page. So creating a file. Deleting a file. You can delete an existing file. You have an existing file in the hard drive that you can delete. And if you delete it, the entry will also be deleted from the content page. That means your file entry will be deleted also from the directory structure, because directory structure is containing all those informations. List a directory. You want to see the entire directory. You want to see the entire content page. Renaming a file. You have already a file, and that you want to rename. Traverse the file system, like directory, then subdirectory. Under the subdirectory, there may be another subdirectory, and here you have the file. Like this. Traverse. You can traverse. You can traverse. You can traverse like this. You can traverse. Now, how do you measure the efficiency of a directory? How efficient? So it is how efficient is locating or quickly locating a file. How quickly you can locate a particular file in your drive or directory. How easily it can detect a conflict. What is the conflict? You have already a name, you have a file, and you are creating another file with the same name. How easily it can detect the conflict. How you can make a group of the files and assign it to a particular user to access it. So these are all directory structure. Maybe you have a directory, you have a subdirectory. This is subdirectory. Owner, you are the owner. U1. You want to give access to this subdirectory to U2. That means U1 is the owner. U1 wants that U2 can access this directory. So whatever the file you have, that will be accessible by U2. So how quickly it can be done, that is also the functionalities of directory, and that is managed by, again, operating system. Now this directory structure can be in a different level. It can be a single level directory. You have a C drive, D drive, or E drive. In the first level you have a directory name. This is one directory, this is another directory, this is another directory. Under the directory you have files. These are the files. The different files are there. So one level. So as it is a one level, so there can be a issue of naming. So you cannot keep two directory with the same name, because this is only one layer. You have only one layer. You can't keep two directory with the same name because you have only one layer. Grouping problem. You cannot keep number of directory and subdirectory in one group because you have only one layer. So this is the very simplest one, single level directory. Of course, the next one is multi-level directory or two-level directory, where you have user 1, user 2, user 3, user 4. User 1 has this group. So this is one subdirectory, this is another subdirectory, this is another subdirectory, this is another subdirectory. This is one subdirectory, this is another subdirectory, this is another subdirectory. These two subdirectory are under user 2. These two subdirectory are under user 3. These three subdirectories are under user 4. Now so cat is one subdirectory. Under cat, this is the file. Under BO, this is the file. Under A, this is the file. Text, under this is the file. So again, the advantage is, as you have a two-level directory, so you can keep more number of partition. You can keep, suppose you can have, this can be your ABC, this can also be ABC. No issue. This can be your cat directory, this can also be cat directory, because under two different user. So two directory may have the same name under two different user, but in earlier case it was not possible. But the disadvantage is that suppose user 2 wants that user 1 should access this one, or user 2 wants this particular file should be accessible by user 1. This cannot be done by one level or two level directory. This can be achieved by a tree structured directory with acyclic graph. Suppose this is the file under this, which can be accessible by another way. So this particular file is a shared file. This particular file is a shared file. This directory or subdirectory, whatever you say, this is shared among these, and these. So that is the advantage for acyclic directories, which is not possible for one level directory, single level directory, two level directory, even for multi-level directory or tree structure directory. For tree structure directory, you can create any number of level. The advantage is just you can traverse easily. You can traverse easily. You can traverse easily. You can traverse in any layer, any level. But to make a directory or file accessible by more than one people, then you have to make it a shared directory or shared file, and that can be possible by acyclic graph. So all these structures are again maintained by the operating system. Unless you have the operating system, you are no way to do those things. বলো এই পর্যন্ত কোনো কোশ্চেন আছে কারোর? ঠিক আছে for now today. Okay, thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thanks.
Thank you, sir.
Thank you, sir.